Hi, welcome everyone. In this video, I will teach you the topic Determinant of a 3 by 3 matrix. Before you can understand what I'm going to do here in this video, I will advise you to go and watch the lesson video on transpose and determinant of a matrix. That lesson video is basically for 2 by 2 matrix. So knowing how to calculate 2 by 2 matrix is a prerequisite to this lesson. Now, on the board, I have the question, given the matrix C, find the determinant of C. C is a 3 by 3 matrix. To find the determinant, there are two methods I will use to teach how to find the determinant of a 3 by 3 matrix. The first one is the cofactor method. That method, for example, if I rewrite this matrix in this form, okay, now this is still 3 by 3. I want to use this to explain what I'm going to do here. Okay, the first row, the elements are A, B, and C. I'm going to take each element of the first row, and each element I take, I will remove all its elements in that same row and column. For example, A, all the elements in that same row and column will be removed. And if I do that, I will only have E, F, G, H, I. That's what I will have left. Then what it says is use that A to multiply the determinant of this minor matrix. So I will write determinant of C will now be A times the determinant EI minus HF. Then minus, taking B into consideration, I will remove every other element in the same row and column. And I will have, so B, what I will have left, if I remove every other element in the same row and column, I will have D, F, G, I. Then the determinant is DI minus GF. Then the last one is C. So if I'm considering C, I will remove every other element in the same row and column, and the minor matrix I will have is D, E, G, H. And the determinant is DH minus GE. So with this formula, you can easily implement the determinant of the real matrix given in the question. So the first row is 4, 2, 1. Taking 4 into consideration, removing everything in the same row and column, I will have 5, 2, 1, 4. Then the determinant of this 2 by 2 matrix is 5 times 4 minus 1 times 2. Minus, the next one is 2. When we are considering 2, everything by the row and column will be removed. We will have 1, 2, 2, 4 as the minor matrix. Then the determinant is 1 times 4 minus 2 times 2. And lastly, the third one, which is 3. If you consider 3, remove everything in the same row and column, we will have 1, 5, 2, 1 left. Then the determinant is 1 times 1 minus 2 times 5. Okay, continuing, I will have 4 into 5 times 4 will give you 20 minus 1 times is 2. Then 1 times 4 is 4 minus 2 times 2 is 4 plus 3 into 1 times 1 is 1 minus 2 times 5, which is 10. The next line will have 4 bracket 18 minus 2 bracket 0 plus 3 bracket minus 9. Multiplying this, we will have 72 minus 0. This will give you minus 27. So 72 minus 27 will give us 45. So 45 is the determinant of C. Then, using the second method second method is called SARRUS rule. In that SARRUS rule, what you do is the 3 by 3 matrix, you make it 3 by 5 matrix. You increase it to 3 by 5 matrix. How do you increase it? You repeat the first column and the second column, the first column and the second column. So this is what you have. Instead of having only 4, 2, 3, 1, 5, 2, and 2, 1, 4, you expand it by repeating the first column and the second column. So we now have 2 by 5, 3 by 5 matrix. Now, the next thing to do is you add the product of all the leading diagonals. The leading diagonals are, this is the first one, the second one, and the third one. These are the leading diagonals. So find the sum of the products of these 3 diagonals. And we'll have, so the determinant of C is equals to the product of the first leading diagonal plus the product of the second leading diagonal plus the product of the third leading diagonal. Whatever you get from the sum, you use it to subtract the sum of the other diagonals. So the other diagonals here are this one, number 1, this one, number 2, and this, number 3. So find the product of each of these other diagonals. We have 2 times 5 times 3 plus 1 times 2 times 4 plus 4 times 1 times 2. Okay, continuing, we'll have this. The first bracket will give you 80 plus this one will give you 8 plus this will give you 3 minus this will give you 30 plus 8 plus 8. We will have, if you add this, you will get 91 minus, add this, you will get 46. If you do the subtraction, you will get 45. So 45 is the answer. You can see that the answer we got using the cofactor method is the same answer we got using the SARRUS rule. So whichever one you find comfortable using, please use that one. As long as you use the method correctly, you will arrive at a correct answer. Thank you for watching, and bye for now.